aware of that. All right. So like we'll probably have a lesson today and a lesson tomorrow and then maybe a work day, right? So you'll probably have less work days. So just wanted you to be aware of that. So on that note, we'll go ahead and get right to it. And virtual kiddos, just try your best to follow along as best you can, you know, without the note template. All right, so chapter 7 is going to be all about exponent rules and stuff like that. We have previewed this a little bit in our DMR, but with our lesson now we'll get a little bit more into detail. Robert, you're gonna have to sit down, get it sorted out, buddy. We're going. Okay, you're like in the way. Sorry. All right. So two main properties that we're looking at today. You got your zero exponent property that says that, and this is one of those things that it's kind of counterintuitive, but basically it says that any number that's not 0 raised to the power of 0 is equal to 1. Okay, if I ask you to guess what the answer to that would be if I raise anything to the power of 0, you'd probably say it'd be 0, right? But it's actually equal to 1. You've probably heard that before, but it's been a while. So again, you just have to remember that. And we have touched on this one in the DMR, the negative exponent property, that basically says that if I have a base raised to a negative exponent, that is equal to the reciprocal of that base raised to the positive exponent. Okay, which is kind of a lot to say, but I think it's best and easiest to learn through examples. So let's go ahead and start them. All right, so in example 1, where you're taking an actual number base to a power, you can use your calculator to help, okay? And once we start helping on the Math XLs and stuff, I can get more into that. But for right now, you can just try to figure that out on your own, okay? But I'll show the work algebraically. So if I have 9 to the power of -2, I want to get rid of that negative on the exponent, okay? So I want to take the reciprocal of the base. I like to write that out this way. The reciprocal of 9 is 1/9. And once you do that, the negative on the 2 goes away. So I like to write it this way. I don't care if you write it this way. In fact, this is how the math book shows it. But both of those mean the same thing. Because, you know, 1 squared is equal to 1. Okay. I like to think about it this way. If you prefer that way, that's fine. Either way, though, we can simplify that because 9 squared is equal to 9 times 9, which is 81. So my final answer here would be 1/81. Okay. So, you know, if you typed in 9 to the power of -2 or 9 caret key -2 on your calculator, it's going to give you whatever decimal this is equal to. Okay. And like I said, we'll look more at that when we're working through the practice together. Example B, -3.6 raised to the power of 0. Okay, that's one of those. Again, you just remember anything to the power of 0 is equal to 1. Okay, whether it be 25 million raised to the power of 0 or whether it be -3.6 raised to the power of 0. Just got to remember it. Looking at C, again, that's just similar to A. You wanna take the reciprocal of the base here. So the reciprocal of 3 is 1/3. The negative on the exponent goes away at that point, and then we just think, what's 3 to the 2nd power? That'd be 9. So overall, this would just be equal to 1/9. And again, so if you just typed in 3 to the -2 or 3 caret key -2, your calculator is going to give you 0.1 repeating, which is equal to 1/9. Okay? So on that note, I want you to try the next couple or next 4 on your own. And when I say on your own, you guys feel free to compare answers if you're in person, because I will call on you. Okay? This is kind of instead of the Ed puzzle questions, this is how I'll check for understanding. I'll give you a few minutes to do them, and then I'll call on you. Okay, so I'll kind of walk around. You guys just kind of grab me if you have any questions. And again, feel free to compare answers. as you work or at the end. So you're doing 4 times 3 there. You did the right first step. 4 times 3, 4 times 4, 4. So do you have a calculator? Okay. I like that. I like that. And guys, you know, mistakes will happen when I call on you, right? So we're just doing these, some of these for the first time. So, you know, get used to you getting called on, and sometimes you'll get it wrong, and that's okay. It's not the end of the world. Yeah?
I have a question on
You better hurry. We're about out of
I have a
time.
question on.
Okay.
I don't. Is this fraction for already? Do we do the reverse?
Yep. All right. So looking at example D, Grant, did you get anywhere on that one? 4 to the negative 3. 1 over 64 is correct. Very good. Now, I'm just going to put the answers up here, okay? The filled out notes will be posted later, but if we have time at the end and you were not sure how you got that, you can ask at the end. We're just doing answers only here. Shanna Hackett, can you tell me what E is equal to? Negative 5 raised to the power of 0. How about Josh Carey? Negative 5 to the power of 0. What's that equal to? No, it's not 0. Robert, what is it? 1. Anything to the power of 0 is equal to 1. And you just have to remember it, okay? Bree Styles, what about F? Did you get anywhere on that one?
Is that 1 over 6?
1 over 6. Very good. And the next one is tricky, okay? So I'll send it out to a volunteer. Anybody think they know what 1 over 4 to the negative 2 would be equal to? If you're pretty good with your calculator, you could type it in, and it gives you nobody, no bold souls out there? All right, so I would say that, you know, it can be written this way, or it could be written this way. 1/4 to the power of negative 2. For whatever reason, this makes more sense to my brain, okay? So you got a negative exponent. We want to flip the base. 1 over 4, the reciprocal of that is 4 over 1, or just 4. The negative goes away, and then we simplify. 4 squared is equal to 16. So hopefully some of you guys had 16 and were like, man, I should have helped there. I should have shown everybody how smart I am. All right, so example 2 is going to be a little bit tougher because you can't check all these in your calculator, right? You have variable bases, so these are a little more abstract, okay? Anyways, let's go ahead and get right to it. So looking at A, you have 5, and that's to the first power, A to the third power, and B to the negative 2. So really, as far as simplifying goes, your eyes need to just see the one that has the negative. Everything else is simplified, okay? So really, the B base is the only thing we need to worry about. So then we kind of think 5 is going to stay 5, A cubed is going to stay A cubed, but we're going to flip this base. So now I want to work everything out, right? So my numerator is 5 times A cubed times 1. Or we would just say, simply put, 5A cubed. So 5A cubed, we don't need to put the times 1. Now what's on my denominator is just B squared, okay? So all that's over B squared. All right, so that's one people tend to struggle with right there. So if that one's tough, we'll see a couple more like it, and you'll get it as we go, okay? Any questions just like sticking out to you on that one? Okay, that's fine. All right, looking at B, the math book or Math Excel is going to write it this way, 1 over x to the negative 5. I prefer to think about it this way. 1 over x raised to the power of negative 5. So now I can flip it. The reciprocal of 1 over x is x. Once I flip my base, then the negative on the exponent goes away, so that just simplifies to x to the positive 5. Or x to the 5th. That's how you would normally say that. All right, and then the last one's pretty simple. Go ahead and flip your base. The reciprocal of x is 1 over x. So the negative up to the exponent goes away. I think Math Excel would accept that, but if they didn't, they would want you to write it this way, 1 over x to the 9th. I would probably use the word or there. I think they would take it either way. All right. Any questions before I have you guys try a few then? All right. Very good. Try your best. And again, be willing to make those mistakes, okay? I know this is not ideal with the layout where you have to flip back and forth, but, you know, just do your best on this example. And again, I'll just kind of walk around while you guys are working so that, you know, if you have a specific question, that's what I can help the best with. Feel free to compare answers with your neighbors too. Hard over here. Other than that. Nailed it. Nailed it. Okay, we gotta get you working for it. So I wonder if it looks like it. That looks pretty much like it. If you'd have written it down, then you'd have something to go on. Yeah. Yeah. Well, you just changed the number. That should be 3. So yeah. Oh, I wrote it down. Yeah. So yeah, you got the right idea. You just changed the 2 to a 3. But yeah, most people get that one wrong too. So that's good. So you can't just drop the negative. You gotta do something to the base first. What do you do to the base in order to drop the negative? You gotta flip it. So like the reciprocal of C would be 1 over C. So I would just ask you, why'd you take the reciprocal of the 2? All right, so these, like I said, are going to be a little bit tougher, so I'm going to call on probably more people here because there will be more mistakes, and that's okay. So Lily Phillips, what'd you get for D? N to the 3rd is correct. Very good. N to the 3rd is correct. And notice we don't write n to the 3rd over 1 because we don't need to. That wouldn't be fully simplified. Caleb, were you able to get anywhere on E, buddy? What about, can I get a volunteer? Because people tend to get that one wrong. Grant?
4B.
That's exactly right. Very good. So 4B stays on top because 4 has a positive, B has a positive exponent. And so the negative exponent I'm dealing with is the exponent of C. So you think 1 over C cubed. Everything else stays on top. And again, on my filled out notes, these are more detailed. I'm just showing kind of the answer only at this point. All right. Nice job, Grant, there. Robert, were you able to get anywhere on F, 2 over a to the negative 3.
I was gonna use
Kevin, did you get anywhere on that one? If it's an emergency, I'd rather you stay, but.
I can win it up here now.
All right, so a to the third over 2 is a common wrong answer. Can anybody correct that? It's not a to the third over 2. Robert?
You probably have to simplify it 2 and make it a 1, which means probably.
No, that's not it. Anything else? Adrian?
A over 2 to the third.
A over 2 to the third. No, it wouldn't be that either. Anybody else got one last try? That's all right, though. You see how these can get a little bit tricky, Grant?
2A.
That's it, 2a to the third, right? So again, what's the exponent of 2? It's positive 1. So 2 doesn't change. It stays in the numerator, okay? The only thing that changes is this one, right? So if we flip 1 over a, we get a over 1. So now that brings the a up top. And then its exponent becomes positive 3. So altogether, it's 2a cubed. And that's tricky. You just saw how many people missed it. So good job. All right, and then the last one, Cameron, were you able to get anywhere on that one? We had n to the negative 5 over m squared. All right, just throw it out to a volunteer. Robert?
It would probably be, you have to make the negative 5 to the denominator.
Just an answer would be good.
Okay. N squared over n to the 5th power.
Okay, that was basically the same mistake that Kevin made on the first one. All right, so you got the right idea. Josh? No, it's not that. Anybody got one last try? All right, so let's think of these as well. If we break them up as 2 different factors, right? You have another way to write this term would be 1 over m squared, and that's got a positive exponent, so it doesn't change. And then you also have n to the negative 5 over 1. So this is the one that needs to go down bottom, right? And then that's where you'll have the change in signs to the exponent. So altogether, you'd end up with 1 over m squared times n to the positive 5. One over m squared n to the 5. And the order of the letters doesn't matter there. That could also say 1 over n to the 5th times m squared. All right. The big thing is, does it end up in the numerator or the denominator? Okay. All right. Any questions before we move on? Okay. So really the last example I want to get through is example 3. We can probably just skip the word problem. Okay. So those of you who have a calculator here will have the advantage. Okay. All right. So the only difference with these is that they give you a value for your variable. So in example 3a, our expression is 3s cubed t to the negative 2, but they give us what s is and what t is. So first step is we're going to sub in. So that's going to be 3, and then you're going to want to use parentheses here. So 3 sub in 2 instead of s. So 3 times 2 cubed. And then sub in negative 3 instead of t. Now, if somebody kind of knows how to type that in, can anybody type that in for me real quick, just like you see it? So 3 parentheses 2 to the 3rd, parentheses negative 3 to the negative 2. Anybody try to type that in for me real quick? I think you might have missed a negative maybe. Did you type it in as -2, that exponent? Yes. All right. So when you type it in, it gives you, if you type it in correctly, it gives you 2.6 repeating. Okay. So I want to show you why. All right. So the one with the negative exponent goes downstairs, right? And so what we end up with then is when we simplify our exponents, 2 cubed is 8. So this is equal to 3 times 8 is 24. Actually, let me just keep that as 3 times 8. So 3 times 8. And then on the bottom, that ends up being +9. Okay, +9. So, you know, that's 24 over 9, which ends up being equal to 2.6 repeating. Okay, Math Excel wouldn't take that, right? So we want to be able to write that as a fraction. So back to what Adrian said, there's that fraction to decimal key, and that stuff we'll go over when we go over the homework. Okay, so there's a button that would convert Adrian's answer to a fraction. You probably know where that is, but if not, that's a good Math Excel day question. But if I just reduce this, here's what I end up with. I end up with 8 over 3, or that's 2 2/3, which guess what that's equal to? 2.6 repeating. Okay. All right, so let me do a couple more. Make sure, yeah. We might just finish up with these two, and then I'll post the homework, and then you can see those last two on the filled out notes. All right, so for these next two, n is -2, w is 5. So plug in first. That would give me -2. The parentheses are important there. Raised to the -4th. And then I'm not even going to worry about what w is because it's raised to the 0. So I know that's just going to be 1, whatever w is. Right? So that just tells me if I'm multiplying, I just ignore it basically. Okay? So really I'm just worried about this. So that's going to be 1 over -2 to the 4th. So -2 to the 4th is +16. So this would be equal to 1/16 or 1 over 16. And then let's just finish, like I said, with one more. Okay. So we'll go ahead and sub in first. N is -2. And W is 5. I'm going to go ahead and take care of my negative exponent. So that's going to go downstairs. So then that's going to give me 1 over -2 to the 1st times 5 squared, which is 1 over -2 times 25. And again, you probably don't need to show this much work if you have a calculator. But that's going to give me -1/50. And again, think about that. If you type it in right from here, your calculator is just going to spit out the answer, -0.04. But now we know like why. Okay? So I threw a lot at you there pretty quick. The filled out notes will come later. The recording will be attached. And I would suggest you at least try to do your homework as homework or a study hall later, because we'll have another lesson tomorrow, but then we'll have kind of a review day on Wednesday. So that'll be kind of how it goes as long as it seems to be working for you guys. So hopefully, I'm excited about it. Hopefully you are too.